All right, class. So today's session is about the topic kinematics. And kinematics is basically, first, the definition of kinematics. It is that branch of physics which deals with the motion of objects irrespective of the source. It means that we are not basically willing about, for suppose if somebody is driving a car, so we are not basically concerned with who is the driver, but we are concerned with the motion or speed of the car, or the distance it is traveling, or acceleration it attains in particular time. What was the time for a car to travel the distance from one point to another? So this is basically a type of kinematics, in which we discuss the motion of different objects which are moving, or they are basically heading in a direction. So in kinematics, first of all, you should know that what are your objectives of learning. So your objective learning is definitely, number one is that what is meant by speed and velocity. Then you will come to know how to calculate average speed using distance traveled divided by time taken. That is the formula to find the average speed. You can also say the total distance traveled by the total time taken. Then you will be able to basically understand, or you can state what is meant by uniform acceleration, and you can calculate the value of the acceleration using the formula, that is change in velocity divided by time. As you can see that we can use a formula of final velocity minus initial velocity divided by time to find the acceleration, or we can also find the deceleration in the same way. Then the next basic objective you need to learn in this, you are going to learn in this topic, is how to interpret given examples of non-uniform acceleration. And then ahead coming, the next point or next objective for you is to plot and interpret a displacement time graph and a velocity time graph, to understand how these graphs are basically drawn for the movement of different of a body who is moving in a particular direction and having a speed which is basically varying. So we can have that idea about plotting those displacement time or velocity time graph. The next basic objective for you to learn will be deduced from the shape of the displacement time graph when a body is, number one, at rest, number two, moving with uniform velocity, number three is moving with non-uniform velocity. You can also find the total distance covered in this particular basically this distance displacement time graph. And then the next objective is how you can deduce or find the basically shape of a velocity time graph when a body is number one, at rest, number two, moving with uniform velocity, number three, moving with non-uniform acceleration, and moving with uniform acceleration. So this is you are going to learn in the velocity time graph. Definitely the velocity time graph basically gives you different things which are coming ahead, and you will be you will have the knowledge of all those basically quantities in this particular objective. The next objective for you to learn will be calculate the area under a velocity time graph to determine the displacement traveled for motion with uniform velocity or uniform acceleration. Then you will be learning to state that the acceleration for free fall for a body near to the earth is constant and is approximately about 10 meters per second square. And the last objective of for this basically lesson called kinematics will be the describe the motion of bodies with constant weight falling with or without air resistance, including reference to terminal velocity. So these are the objectives which you are going to learn in this topic called kinematics. So we are moving towards our first objective, which is state what is meant by speed and velocity. So basically, uh, these are two different quantities. When we talk about quantities, physical quantities, and before that, a quick review about what is a physical quantity. So any quantity which can be measured is called a physical quantity. For example, length, mass, time. These are all basically physical quantities. So in these two types of quantities, we have some quantities called scalars, and we have the other type of quantities which are called vectors. And you already know in the previous chapter, the scalar quantities are those which are completely specified by a magnitude and a unit, whereas for vector quantities, magnitude and a unit is required along with the direction. So any quantity having direction is along with magnitude and a unit is called basically a vector quantity. Some simple example for scalar quantities are mass and time, which only has magnitude and a unit, whereas for vector quantity we have weight, force, which also has a direction, or for example velocity, which also has a direction. And so we have the idea about the scalars and vectors. Now, coming back to the speed, basically, speed is a scalar quantity because the definition, by definition, basically, speed is the distance covered in a unit time. So it doesn't require any direction. And if you look at the speedometer of a car or of a moving vehicle, so you can easily analyze the reading over there is from, for suppose, 0 to 220, then the needle will indicate a particular basically speed of a car. So you can say that at a particular time the car is moving with a speed of 40 kilometer per hour or meter per second, whatever the basically unit is given in the speedometer. So speed is again the distance covered in a unit time. Unit means per second or per minute or per hour. So there are two basically units to measure speed. One is meter per second, which is the SI unit, and the other higher unit is kilometer per hour. So you can easily convert kilometer per hour to meter per second by applying appropriate, conversion. So about velocity, velocity is, as I told you, that it is a vector quantity, and a vector quantity is that which requires a magnitude, a unit, and a direction. So we say that distance covered in a particular direction by an object is called the velocity of that object. So again, the distance covered in a particular direction per unit time by an object is called the velocity of that object. By the way, the SI unit in which we measure both quantities is meter per second or kilometer per hour. So this is basically, if one question can be asked about the difference between these two quantities, is that you can say that the basically speed is the distance covered per unit time, but the velocity is distance covered in a particular direction per unit time. And speed is a scalar quantity, whereas velocity is a vector quantity. And a symbol through which you can basically represent speed and velocity is, again, I'm just drawing it with the help of this pen to make you understand what is the difference in writing the symbol of speed and, by the way, velocity, because they both are different quantities. And I'm trying to just draw these symbol of this basically these quantities in a proper way. So both are represented by V, the letter V, but for velocity, we will have a dash or a arrowhead to represent the direction. So this is basically speed, which is a scalar quantity, and this is basically velocity, which is a vector quantity. All right. So the third difference between these two is the representation of these two quantities. If you represent the speed, you will only write the symbol, the letter V. And if you are going to represent the velocity, then you will be writing V with an arrow overhead or a dash you can use. So this is what was the definition of these two physical quantities, and you come to know about the difference as well. Sometimes the definitions can be asked, and sometimes you may be asked about writing two or three differences between these two quantities or the quantities coming ahead. So now we the second basically objective of this topic was to calculate average speed using the formula, that is total distance divided by total time. So first I would like to write the formula of the average speed, which is VF, that is average speed. It is I can write it in symbol to make you people understand easily that it is the total basically distance. Just a second. So if you represent, for suppose, distance by S and the time by T, and you can write small or capital T for total distance and TT for total time. So this would be the formula for your basically average speed. So if numerically, for suppose, if you have the distance, total distance covered by an object approximately equals to 500 meters, let's say 500 meters, and the total time taken by that basically object was 10 seconds, then by applying the formula you can easily find the average speed of this object to be, that is 500 divided by 10, and you have the answer as 50 meter per second. So this is the average speed of that particular moving object, 50 meter per second. It means that the car has basically covered 50 meter distance in each second. Averagely means in each second, if it is covering 50 meter, then definitely after 10 seconds it will be covering 500 meters. So this is how you can find the average speed by using the formula total distance over total time. And by the way, we can easily basically manipulate this formula to find uh, total distance also if the average speed and time is given, or total time if the other two quantities, that is average speed and total distance, is given. So I always basically uh, I always just try to make my student understand by knowing how to find any unknown, as we have a triangle like, in which we have all these three basically quantities, physical quantities, and we can easily remember the formula which we need to find the unknown. So I have written basically three quantities in this triangle, in which total distance is written in the place of numerator, where there are two denominators, that is average speed and the total time. So if I put the thumb on any of the single quantity, then I'll have the formula of that quantity. For suppose if I want to find the total distance using this formula, so that my total distance will be the average velocity multiplied by total time, right? So in this way, if I want to find the total time, then it is going to be basically the total distance and divided by average velocity. So if I put the thumb on any one of the symbols, I can get my formula ready to find that unknown. So this is a basic trick of finding any quantity, which is basically to be found if the other two quantities are known. So as we have basically calculated the average speed by using formula, that is distance traveled or total distance traveled in total time. Now basically we want to express, or we want to basically describe what is meant by uniform acceleration, and how can we calculate the value of acceleration using the formula, that is change in velocity divided by time. So first of all, acceleration. What is acceleration? Acceleration is basically the rate of change of velocity. It means that in a particular time, if velocity changes, basically, so you can say that the speed of the object is increasing. For suppose velocity of the object is increasing or decreasing. So if the velocity changes with respect to time, then we have the acceleration. And again, by definition, it is the rate of change of velocity. So students, whenever you have you hear the word of rate in physics, it means divided by time. So if I'm saying that the rate of change of velocity, it means that the velocity, basically change of velocity divided by time, is the formula for acceleration, which I am writing on this basically board also, to make you understand. The basically acceleration is the change in velocity. You can say that if, for suppose, v is the final velocity and u is the initial velocity and t is the time taken, then this is going to be the formula to find the acceleration. Now, first, keep the definition of the acceleration in your mind. Then you can easily have the concept of the uniform acceleration. As I've said that if, for suppose, instantly, if a car is basically uh, speeding up by 10 meters per second, every second its velocity increases by 10. For suppose for 1 second the velocity was 10, and on the other second the velocity was 20, and on the third second the velocity was 30. It means that every second the velocity of the object or the car is increasing by 10 meter. So because we have the same value after every second for the distance, and the speed basically is referring that it is moving with basically a uniform speed. So acceleration is when the speed increasing by equal basically interval. So if the speed is increasing by 10, then you can say that there is a uniform acceleration of 10 meter per second every second. That is why we have the unit of acceleration as meters per second squared. It means that in every second the velocity of the moving object is changing by a certain, number meter per second. So a uniform acceleration again referring to if the velocity of an object increasing by the same amount. So it is called uniform acceleration. Just as you can also have the idea of uniform deceleration. For suppose the brakes are applied and an object is coming to rest, but before coming to rest, it is decreasing its velocity, and the velocity is decreased by, for suppose, 15 meters per second in 5 seconds, and it comes to rest. So it means that every second the velocity is decreasing by 15 meter per second. So after 5 seconds it comes to rest. So it means that 75 was the basically velocity before the brakes are applied, and when the brakes are applied the velocity decreases by 15 meter per second, and then after 5 seconds it comes to rest. It basically refers to a uniform deceleration in which the basically velocity of the car decreases with the same amount or magnitude. So the thought about the uniform acceleration and deceleration is basically given. I hope you people have understood. And then the formula which I have written to basically find the acceleration, and I am basically just having a problem to understand this formula for you people. And for suppose if it says that the initial velocity of an object represented by which is represented by u is basically 20 meter per second, and the final velocity of that object was 140 meter per second, in the time taken to increase this velocity was, let's suppose, 6 seconds. Then what was the acceleration of the object or of a car? So you can easily see that we have got the initial velocity as 20 meter per second, we have the final velocity as 140 meter per second, and we have the time, that is 6 seconds, in which the velocity of the car changes from 20 meter to 140 meter per second. So now applying the same formula as above I've mentioned, that is change in velocity divided by time. So we can easily see that by putting or substituting these values of initial velocity and final velocity and time, we can have 140 minus 20 over time is 6 seconds. So this is an easy calculation. That is 120 over 6 and the acceleration to be found is 20 meter per second square. So here you got your answer of the acceleration when there is a change basically of 120 meter per, I mean the speed was changed from 20 to 140, 20 to 140, that is 120-meter difference, and in 6 seconds. So it means that the car has accelerated at 20 meter per second uh, square, means that it has gained the speed in every second 20 meter per second, and after 20 meter per after 6 seconds it has the speed of 100 and basically 40 meter per second. So this is how you can easily find the acceleration of an object of a body in the given example, if it is changes from a certain I mean speed or velocity to another velocity. So one thing which you want to remember is that basically the symbol of the unit, that is initial velocity, is represented by u, the final velocity is represented by v, and the time is represented by t, and then you find the acceleration which was required. So this is how you can find the acceleration of the object by using the formula, change in velocity and time taken. So now we can have some basically examples of non-uniform acceleration, as it is mentioned in the objective, one of the objectives which is coming ahead. I mean, how can we have the examples of non-uniform acceleration? It means that, for suppose I give you an example that a car starts from rest. Now, also remember that whenever the word rest comes into the numerical or problem, it means that the initial velocity of the object was, or the body was, zero. For suppose a car starting from rest mentioned in the statement, then you instantly know that the initial velocity of the car is zero. Or if it is stated that the car was traveling at a certain speed like 20 meter per second or 40 meter per second at a particular time, then you can basically assess it or assume this as your initial speed. Otherwise, if the statement is like the car starting from rest, then you can easily recognize your initial velocity, that is u, to be 0 meter per second. And I say that in the first 3 seconds the car basically attains a speed of let's say 40 meter per second. I mean the speedometer or the pointer was basically indicating the speed of the car to be 40 meter per second. But in the next 2 seconds the car accelerates and the speed moves to 70 meter per second. And then in the final 3 seconds the car basically decelerate and the brakes are applied and it comes to rest in 3 seconds. So if we analyze that in the first basically 3 seconds, that is time one, in which the car basically was having a speed of in for suppose 3 seconds the car attains a speed of 40 meter per second. It is traveling with the speed of 40 meter per second. And then basically there was time 2, let's say for 4 seconds it basically goes to, let's say the speed of the car was 90 meter per second. Then in the last 3 seconds the final speed becomes basically 0. So you can see that in all three times, basically, the speed was different in different times. So in the first time, when it was 3 second, the car was I mean the speed of the car, velocity of the car was indicating 40 meter per second. Then in the next basically 3 second, in 2 seconds, basically 4 second, it becomes 90 meter per second. It means that in the first basically 3 seconds, the acceleration of the car was to be 40 divided by 3, and it should be basically less than I mean more than a little more than 13, that is 13.33. So it means that after that 4 second I mean 3 seconds, sorry, for the next 4 seconds, the velocity of the car or speed of the car increases by 50 meter. So it was not the same distance as it was traveling in the first 3 seconds, that is 13.3. Now, if we find the acceleration of these basically 4 second, next 4 second, then it should be found as 22.5, which was much greater than 13.3. And then in the last 3 second, it basically comes to rest. So definitely the speed was going to be decreased, I mean appreciably. And then we can assume that the acceleration or deceleration, whatever, was not uniform, because in particular time the car or the moving object was not traveling the same distance in a particular time. So this is how we basically have the concept of non-uniform acceleration, and we can easily understand it with the help of a graph. For suppose if we have a velocity time graph, so the same problem can be understood by this graph. Is for the first 3 seconds, the car was having a speed of 40 meter. So this was the acceleration of the car basically. And then in the next basically 4 second, that is the time was 7 second, then the velocity of the object of or car becomes 90 meter per second. This means that this car basically has accelerated in the next 4 seconds, and let me correct it a little bit so that I can have a straight line to make you understand properly. So this line referring that it accelerates basically, and then in the next 3 seconds, that is when the time was 10 second, it basically comes to rest. So this is basically representing a non-uniform acceleration, and this basically the line which is throughout basically going up and down and having a steep slope. It is basically your acceleration. So these lines are referring to your acceleration, and this is the type of non-uniform acceleration. Otherwise, very simply, you can have the idea of uniform acceleration, that is like this in a velocity time graph, and you can also have non-uniform acceleration like this curve, or you can have an upside curve like this. So these two are representing non-uniform acceleration, and whereas whenever you have a uniform acceleration or uniform deceleration, you will always have a straight line like this. This is uniform deceleration and this is uniform acceleration. All right. So these are the simple symbols for you to remember the uniform acceleration and uniform deceleration to assess your basically requirement. What is the objective or what you want to find in a graph or numerically regarding the acceleration. So and these were the examples regarding the non-uniform acceleration. Now we are coming to ahead to a very interesting topic, that is plotting and interpreting a displacement time graph and a velocity time graph. So first we will see a displacement time graph, and which is very interesting for you people. Let me raise this for you to make you understand. All right. Now, in the meantime, I can discuss some of the things, very important things regarding the distance time graph. So, as you can see that the formula for speed was distance traveled in a particular time or distance traveled in a unit time, or you can write distance traveled divided by time taken. So, basically, we first try to understand what we can find by using a distance time graph. So let me write this for you to make it from a distance time graph. All right. Distance time graph. So first thing which you can find from a distance time graph is the speed of the object. Speed of the object. The other thing you can find from a distance time graph is the average speed. And by the way, average speed was represented by the formula total distance divided by total time. Average speed. And of course, you can easily find the total distance covered by the object. Because unless you find the total distance, you cannot find the average speed. Because total time can easily be seen or found by the graph, but total distance basically is a thing which you need to basically focus to calculate or manipulate your results. So first of all, the shape of this graph, the initial shape of this graph is very simple. On the y-axis, we will take distance, that is s, again without any symbol because it is a scalar quantity, and on the x-axis we will be having time. Now one question comes to the mind of students, that why we take time on the x-axis and we take distance on the y-axis. So there's very one simple reason is that there are two quantities. One is dependent and the other one is independent. So time does not depend on speed. If a car is not moving, the time will basically go. It will basically pass on. But the speed is basically dependent of time. So if we want to find the speed of a particular moving object at a particular time, we need to basically consider time as well. And but time is basically independent. So always remember, the independent quantity we always take on the basically x-axis, and the dependent quantity we always take on y-axis. So this is a general form of distance time graph. For suppose you can have, how many shapes can you have for a distance time graph? So you can have basically this type of shape in which basically the line which is going ahead, it is representing, or it is showing the speed of the object, right? Speed of the object. So speed of the object is determined by, again, distance divided by time. And you can assess that, how can you find the speed by using your graph in the coming example. But first we basically explaining, or we are understanding how can we find different shapes, or we can see different shapes to find different speed type of speeds in that distance time graph. For suppose if you have a graph in which the speed is shown like this, then what do you understand by this in a distance time graph? It's very simple. If it speed does not change, it means that the object if the distance basically is not covered, the distance is not covered, it means that the object is at rest, right? So any horizontal line that is parallel to the ground represents that there is no distance covered. So in the same example, if I draw a line over here like this, then it shows that the time basically has gone, but there was no distance covered. It means that there is no speed of the car. So maybe the object was stationary for a particular time at a point, and then it starts again, and which basically can be shown by, again, a straight line going ahead, and then we can draw a line going down like this to show that what was the speed of that object at a particular time. So if I basically uh, name this whole journey in symbols, or label this journey like this is O to A, and this is point B, and this is point C, and this is your point D. So you can easily understand that what is going on in between these basically points. From O to A, you can see a straight line showing that the speed was uniform because the same distance was covered in a particular time. So I'm not writing the time right now, but we'll be having an example later on regarding the time and the distance. But we just want to know the shape and recognize the shape to find some of the speeds of in speed in a distance time graph. So from A to B, you can see that again a horizontal line, and I've told you before that whenever you see a horizontal line, it means that the object was stationary, or it was at rest, and it doesn't move. But from B to C, if you see that a steep line going ahead showing that the speed of the object increases before it was from 0 to A, because it goes up, and it was covering much more distance than the distance in represented in OA. So after that, CD, last point, which basically describes that the basically the speed of the car was getting slower. Even then it was covering a distance, but the basically speed of the car was getting slow, and it comes to rest after a certain time. So this is how you can easily basically have the shapes of a distance time graph. And you already know that from a distance time graph you can find easily three things, that is speed of an object, of moving object, or you can find the average speed, or you can find the total distance, right? So uh, this means that if we have an example of this distance time graph simply, so we can analyze uh, for the same graph. For suppose if I mark here, like this was 5 second, sorry, this was the speed was 10 meter per second, and this was basically 20, and here it was, let's say it was 50. So if for suppose from O to A it takes about 5 seconds, we can say, and then from A to B it takes 3 seconds, that is, and the time was 8 seconds when, and then from B to C when the time was 12 second, let's say, and then from C to D when the time was 15 second. So you can easily understand that uh, in the first 5 second the distance covered by the car was basically 20 meters. So if we want to find the speed at that particular time, then we can easily uh, find it by replacing the value of that is distance, that was basically uh, about 20, and the time was 5 seconds. So it is going to be 4 meter per second. So in the first 5 seconds, the speed of the object was basically 5 meter per second. So in the next 3 seconds, the car basically was at rest. So you don't need to find the distance, because if you even find the distance, then you will not have any distance, I mean speed. So zero divided by anything is zero. So it means that from A to B car was at rest. And then from B to C, if you want to find the basically speed, then in 4 seconds, sorry, because 12 minus 8 is 4.